friends, my name is Tulen Thapa and today I will be teaching you some basics about Scilab and I'm a student of Delhi University Ramjas College and I'm in fifth semester, so I will be doing a problem of fifth semester at the university, and this is to solve the simply to solve the hydrogen wave equation. So hydrogen S wave equation S wave Schrodinger equation है ना for hydrogen. So now I am not so fluent in English, but I will try to communicate as clearly as I can. So let's start without wasting any time. I will be using Jamboard for some explanation also. I have a test tomorrow, so I may not be too much clear about something. So sorry for that. So now we will start. So first we have to write the basic syntax like clear CLC and CLF. This is the basic syntax. These two are for clearing the previous data and clearing the screen that you that have shown the in the console that have shown the values. So and CLF is for clearing the graphic window, I suppose, where the graphs are formed. So let's start. Firstly, we have to understand what we are doing. So I will use Jamboot. So now let's see. We have Schrodinger waves equation as minus. We will use time independent. है ना? So minus h bar upon h square h square upon 2m del square psi upon del x square plus v psi is equal to e psi. This is our Schrodinger. This is our time independent Schrodinger equation. If you want to know about time dependent time, this comes from time dependent Schrodinger equation, which is like something like this: minus no iota h bar del y del t. So you see there, here it comes del by del t and here it comes del by del x. This is psi and it comes out to be minus h bar ka square upon 2m, and here we write del by del t ka square psi plus v psi. Here this is like energy operator, no? So now this is the basic thing. So let's now write this into radial form. We solve this into solve the equation into the square wave Schrodinger equation into radial form. First we have to convert it into radial form. So we take psi as a function of three variable, that is psi, r, comma, theta, comma, phi. As in spherical coordinate system, we have three variables r, theta, and phi. Spherical coordinate system is something like this. We have a simply normal coordinate system like this, and we have a point P, and this is the radial distance r of it from the point O. So this is x, this is so let us suppose this is x, this is y. My mistake, man. So this is y, this is y, and this is z. So now if we like draw a projection of it on the xy plane and draw this like parallel to y axis and parallel to x axis, this line, this is the projection of this vector or this point, that the line joining the point, or simply the vector joining the point O and P. This is point P. Sorry for my bad handwriting. I am writing using a mouse and not using a pen tab because I'm a student, man. So I'm trying to explain the best I can. So now if we see this projection, this we have a long proof for this in our quantum physics class, है ना? It is like in the unit third of the Delhi University syllabus. So now this angle is phi and this angle is theta. You can understand what I'm trying to say, that we try to convert the Schrodinger wave equation, that is del by del x, into del by del r, del by del theta, del by del phi, and this thing is r. So when we rotate all of this will cover the whole area, just like in the Cartesian coordinate system. This is known as the polar coordinate system. This we have learned in I suppose first semester. My ma'am was Charu ma'am. So let's see. This will be this you should know by now, and like this we can write the x, y, and z coordinates in the functions of theta, phi, and r. Just like I suppose, if I'm not wrong, this is r cos theta sine phi, and I suppose I did not remember this, but if we put this try and put this and put drive it, it will be very long video. So I will do that in some other video of I suppose on quantum physics class. So now let's see what we are trying to do. We are trying to solve for only radial wave equations, and the last you will get this, and if you neglect theta and phi, then you will get this, and also there will be a term with L in it, but L for S wave is 0, so that term will be totally neglected. So now if we the final result or the equation that we have to solve in this problem by using the Scilab. Scilab is nothing but a computational software, है ना? So we have to solve this equation. Everyone says what equation we have to solve. This is the main problem in the क्या बोलते हैं main problem in solving this question is that what equation we are solving in our quantum physics in our quantum physics syllabus or quantum physics lab syllabus of the university, we have to mainly solve this equation. Only the value of VR is changing in every question. The mainly you will see, and sometimes this will go here and this will become A1, A2, A, etc. I will do that today only because my test is at 9 a.m. and I am not slept during the whole night, not slept the whole night. So let's start. This is the equation that we have solved. Del square U upon del R square 2m h bar h square ka square VR minus E into cu. Here U is a wave function. We have write it down for simplicity or for suggesting that it is only for we are doing for R only, no? So we have to solve this. So we have this, we have we have to find this or the energy of the state. We have to find this, no? And this thing is given to us like E square minus E square upon R. This is for this question, but for the next question we have this potential difference only. We have minus e square upon exponential minus r upon a. Why I'm writing exponential? Because in the code we cannot write e to the power minus r upon a. So we would do write this e to the power exponential minus r by a. Simply you can write e square upon 2 upon r, but you cannot write e to the power minus r upon a like you can write in the copy. So you write this is simply this only, but I have written it like this because in the syntax you will like it write it like this. In the code you will write it like this. This is the with the screening potential. This is known as the screening potential, and this is the Coulombic potential. For first question we have to do only for the Coulombic potential. So now you may ask what is screening. Screening is nothing but for for like we have shells in an like atom. For not hydrogen atom has only one shell. But if we have cells in the atom, then the electron that the attraction felt by the electron due to the proton is not the same. Why it is not the same? Because there will be repulsion between the electrons and electron also. Two electrons are inside, है ना? And some of the four electrons are outside. And take that four electrons are outside. So this electron will face repulsion from two electrons that are residing in this first cell and is equal to 1. They would repel it, and hence the force of attraction between the nucleus and the outermost shell of the electron would come less. So this phenomena of this phenomena of the repulsion of the electrons from repulsion of the electron means the total force experienced by this would come out to be less, or it will be less bounded, or it will have less negative value, you can say. So less negative value of what? Energy, because negative value suggests that the system is bounded. So now this is known as the screening effect or shielding effect, you may say. I don't know the correct terminology and tomorrow's paper, but it is known as the screening effect. So now let's make the code for the first, in which the v is minus I e square upon r. We have to put just this, and we will be given the question some of the values. So now let's write it down. So in the question we have to first determine the value of always determine the value of some constant. This value of constants will be given to us. These values of constant will be given to us. I simply write it down here. 3.795 m is equal to 0.51 into 10 to the power 6. So these constants will be given to us. Now we will simply write our code. So first we have to determine two. We have to also plot the function. So we can start from here also for plotting that on the x-axis there will be radial distance from the of the electron from the nucleus. in the hydrogen atom in any atom. So the R is the radial distance. For determining R, we simply had to have like R min, that is from where it will start. We will write it as 0.01, and to up to which point it will go, we can write it as 0.8 or 7 or 5, let's say 5. And what will be the step size? So let's take step is equal to 0.01 है ना. Let's take step is equal to 0.01. Now how will we form a vector R, sorry, matrix R that has values from 0.01 to 5 with a step size of 0.01? We can simply write, make it using this syntax: 0.01, 0.01, and 5. Here this represent the here this represents this represents like the the edge, or how much it will jump from this to jump for one point, like this is the starting point, and this is edge, and this is the ending point. It will form a matrix, or you can say it will form a AP type of thing: 0.01, 0.02, 0.03, adding this term to this term, and until it reaches 5. So in generally we do not write like this, because we have to use R min and R max later on also. So we can write it like this: R min, R max, and sorry, R min step and R max, R max. So this is the syntax. Now what we have to do, the Schrodinger differential equation, the Schrodinger wave equation, the Schrodinger equation that we have is like the Schrodinger equation that we have is like divided into mainly the Schrodinger equation that we have: del square u upon del r square is equal to 2m by h bar ka square, and we have vr minus e and u. So now this is the second order differential equation. In our Scilab, we have a command known as ODE, which is used for solving ordinary differential equation of first order. So first we convert this into first order differential equation. We can first order differential equation, no, two first order differential equation. So we can find this by using this syntax. This is a very good syntax. First, we make a function for to break the function into two parts. So first, we make a function that is named like my name, th is equal to uh, th. No. First, we need function. Uh, First, we make a function named f. Firstly, you need to say understand the syntax of function. First, you write th, and then you write down th is equal to, and the name of the function would be the term that you write here. Just like I am writing f, and the variables are written down here: r comma no x comma r comma x comma r comma x comma r comma x comma, and it is e. E is the variable that we have to find, and x and r are like the x and y of normal. We have to write capital no. X and r are like normal terms like x and y in our equation. So now we will write th1 th1 equal to x2, and th2 equal to now we have to write like the whole term 2m, this term, the whole term like 2m upon h bar ka square. So instead of writing this, I can simply write 2m by h bar square as a constant. I can define it upwards, like here I can write c is equal to 2 into m. Let's put this in brackets so that the Scilab does not confuse itself. 2m into 2m divided by h square. Here this h square is like h cut ka square, no, because this is the value of h cut only. We can write here h cut just for hc, just for specifying that the this is like the value of hc, है ना, h cut. So now we can write C into, I have already defined what is the potential, so let's put minus e to the power 2 e square divided by r, and here we have defined r, so it is coming out here, and we have to put this whole into one bracket and again open one bracket and write minus capital E, because we have used capital E variable for energy. So now we have the function, the wave function, no, so we can write this as x1. So this is the main syntax of this whole code, I suppose. And now for solving the first order, the second order, the first order differential equation, we need to know the value of at x0, which is s 0.01. And I suppose this is the given value, that 0.01, and the value of this function, differential of this function at that point, which is coming out to be 1, and what we have to know, and everything is known. Now we have to input two values. For we are doing this question by bisection method, so we have to make sure to input two values or two random guesses from the user. And for inputting two random guesses, let's say both the random guesses are even into, you should write just input and the guess of energy, and you can write like this. And similarly you can copy the statement, control C and control V, and write here A2. So this is by far what we have done now till now. So we have to just take to input, and now in bisection method you know that we have a third variable E3, which is equal to caps lock E1 plus E2, and here E1 and E2 are the values of this, and this is like A, this is like B, and this is like C. You know all know bisection method simply. It's very easy method. So now we can now define another function which is used for solving ordinary differential equation. In this command we can define a function like solve, that means solution is equal to u, and this will be the function of et, let's say. So now we have solve is equal to ode command, and here we like this bracket, and then we use this bracket x0, and this we then we use semicolon. These are important thing, x0, and then we use this, sorry, this one, and x speed o, and then we use this one, and then we use comma r minimum from where we start, comma r from what is the matrix of r, and from for what it has to solve, because it will solve for boundary, I suppose. And this and r min r, and we have to write list and name the functions which is involved, that is f function. Here f function is involved, and the variable et, f comma et. And so this function is done now. This function's name is u. This is the name of the function, man. So now we will write another. Now we will write the value of L, capital L. You will know note. You can also use dollar sign, but I am using this longer method because I learned this only. So L is equal to LENGTS. This is used to find the length of any matrix, and we are finding the length of the matrix UE3. Caps lock, caps lock. Oh my god, UE3. This will find the value length of u3. Now I will be dividing this length. L is equal to, small l is equal to capital L, small l is equal to capital capital L divided by 2. Oh my, capital L, this would be capital L divided by 2. You can also use dollar sign. Dollar sign is used to take the last element of this, of any matrix. I am doing this because I have learned it like this way. First, I will do, this will give us like the last, the last, the number of the last column. So I can, you will see where you can use dollar. You can simply use dollar. So now we are using initiating a while loop, and while loop with absolute value of, if this is for determining the accuracy of the for maintaining the accuracy of the bisection method, and this should be greater than or equal to 0. This is the accuracy thing that we are doing, and here this is the absolute value of even into, because anyone can be larger. So now we have fairly large accuracy, and you can see it automatically provides an end for you. So now we will make mm, we can write this equation here so that it knows what to do, but we have to not have you do not have to write that also, but you have to write that because because here we used E3 to determine the value of length. So now we are writing this for while loop to go through it again and again. So control V, and now you will form two matrices named M is equal to, you will form a matrix named UE3, UE1, UE1, and a matrix named N, which is equal to UE3. E1 and E3 because we will consider E1 as new to E3 as new to E1 as new to. Okay. So now we will put condition if M 1 comma, here you can use dollar sign simply and not do this much thing that I have done. You cannot use this much thing and simply put a dollar sign. This is giving us L because we have selecting the first column, first row, and the last term of the row will be selected by this term, simply because the new the new of any function would give a matrix that is of 2, that will be of 1 would be above, like it will have two rows mainly. So now I have counted the number of the number of let's say I have counted the number of total number of terms in it, and if I divide it by 2, then I will get, let's consider this as the matrix. So then I will get the this term, like this term I will get the column, this column. And if I put restriction that we have to take this column, this row only, then I will be left with only this term, है ना? Only this term if we consider this as a row. I hope you understand. So now if we multiply n 1 comma l, and if it comes out to be greater than 0, so now see, if it comes out to be, if let's suppose e1 into e3 is coming out to be greater than 0. So if e1 into e3 is coming out to be greater than 0, this means this is not our this the e1 is not our solution, or it will not have a solution. So now we'll put e2 is equal to e3. So now if we put else statement here, else statement, else if there is if there will also be an f, else here we have to write uh, then, and else it will come out to be e1 is equal to e3. Simply if e2 is not equal to if e2 is not equal to e3, then something has to be equal to e3. So something matlab, if there have to be one interval, if we have taken the correct value of e1 and e3, e1 and e2, then should be one interval between them that has the root of the solution, root of the equation, or root of the uh, root or solution of the equation. So if we put e1 is equal to e3, we would have completed our simply meaning that we have completed our bisection method here, and we will put an end to this uh, if loop, small end. We will put end to this our if loop, to our if loop, and also to the while loop. Now we have done everything. Now we can simply display the value of E3. That will be our solution, or the hydrogen, the first the ground state energy of the hydrogen atom. This will be our E3. And for plotting we have to we simply have to do like this. For plot we have to do r comma n, because it has a solution n 1 comma, this is taking the complete first row, only the first row, and we have to do it like this and simply play and see what errors are coming. So enter 1 if you want to wave function, or plot anything else if you plot anything else. Enter 1 if you want wave function plot and enter. This is not our thing, I suppose. If I have to, I suppose I have to save it first. I have not don't know what this computer is showing me, so I have to save it. So I am trying to save it. I suppose I have written something wrong. Clear CLC or CLF, है ना? Clear CLC CL. I wrote everything right, man. Still the console. Enter. I suppose it is stuck in the previous code that I have created. So I will just restart Scilab. So now I will just restart Scilab single time. This was the graphic window. That's why I was talking about that CLC will CLF would clear out. So now I will again open Scilab. Let's see what the problem was. It's not opening. So now I suppose it should show. Oh man, this is okay. Let's see if we can run it now. So now I have run it. So now we have to see what error. So this is the error coming out. So we will go back and uh, see to a error. So where is the error was coming here? We have not put multiply sign. So we can do this that we can put the console and shorten it and put it here. So now we will know what errors are coming and we can share simply. So there is another error here and we have not finished the syntax for ODE command. So you have to see every time that you put the brackets and correctly etc. So now we have to put the guess of energy. The guess of energy would be like between -10 to -15. So we put -10 to -15, and here we are getting an undefined variable xpo, and here we put xpa 0 and here we put xpo. That's why it's coming out like this. Now we have again rectified our mistakes, and now we again write here -10 enter -15. I suppose I have written -10 -15 somewhere. So now write like is enter. So at line 2 of the function f od at line 20 on the function and 2 of the function at line invalid index od and error I should have subroutine. I suppose I have again. Let's see into full screen what is the mistake. Hmm. So let's see what we have done. We have done HC and E and M, R min, R max step size. We put the value of R and we put the value of C in it. Function is like f x comma R comma E. Th1 is equal to x2, th2 is equal to C into e square upon 2 upon R minus E into x1. So this much is correct, I suppose. Then x0 is equal to 0.01, xp0 is equal to 1. This is correct. This is correct. Input, we have taken the input, we have dropped the function. I suppose they have syntax errors in this. R min, R max, list f comma et, and function length UE3. So what is the problem coming? Let's see. Let's put the guess of energy 10 and enter -15. At line 2 of the function. What is this? At line 2 of this function. We have to again shrink it down and here. At line 2 of this function, OD and error in the isoda subroutine. I don't know why it is coming out, but like this, but it is like the correct. It is like normally the correct code. You can use this code, I suppose, and it will give correct value. I must have wrote something else. Something I've done. Must have done something wrong. So let's see. I will try to to rectify my error. If I'm not able to, then this will be the end of the video. But I suppose this should work. I don't know what I have done wrong. Let me see. 0.01. Uh, this should be smaller than 0, I suppose. This should be smaller than 0. Because of my I wrote this thing down because if it will come negative, if it will come negative, then this means that these are our new values and E2 has to be replaced by E3. There is an error. Let's see if we have to write it again and again. So I will just erase these and put the value of put the value like minus 10 and minus 10 and E2 can be minus 15. So I don't have to write it again and again. So now what is coming at line 43? At line 43 and like 18. Like 18 is like I have just given the value and I don't know what is coming. I must have done ODA command is also correct, I suppose. At line 48. There is no line 48, 43, man. What are you talking about? Line 43. So what I don't know what error is coming. The C program modulus console input. So I don't know where the error is coming from. So now let's end it for this time. I will again come back with another code another time. Thank you.